Alright, now we're going to start getting into dividing square roots. You can have an example here of square root of 49 over the square root of 4. And we can split that up as a square root of 49 over a square root of 4. So you can rewrite this one square root as two square roots. And then what you can do is you can take the square root of 49, which is 7, the square root of 4, which is 2, and you can either leave it as 7 over 2, or turn it into a decimal. It's just extra work. That's up to you. You have to keep in mind that any fraction cannot have a radical in the denominator. So what you're going to be doing is you're going to be rationalizing it. When we rationalize a denominator, that is just a method that we call, that we eliminate radicals from the denominator. The way you're going to do that is you can multiply top and bottom by whatever's in your denominator. So for example, here on number 13, we have a 4 over the square root of 6. Well, you have a square root of 6 in the denominator, which means you cannot leave it there. And what we're going to do is we're going to multiply top and bottom by square root of 6. When you do that, you end up getting a 4 radical 6 on top. Now on the bottom, keep in mind anytime you take a square root times a square root, or anytime you take it times itself, you just get itself. So your answer would be a 6 down here. Another way to look at it would be if you have a 6 times 6, that gives you a radical 36. Well, the square root of 36 is just a 6. So you can either write out this step here, where you actually multiply the numbers underneath, or you can skip that step and just say, well, anytime I multiply something by itself, it's just going to be itself. Now we're almost done. However, you can still reduce. You cannot cancel a square root of 6 and a 6. You can, however, reduce fractions that are on the outside. So each of these can be divided by 2. So your answer would end up being a 2 radical 6 all over 3. So let's try the same thing on 14. Now 14 looks a little different than 13 just because you only had one square root on 13. Here on 14, we can rewrite this. So we have a square root of 3 on top and a square root of 8. So we can split it up into two square roots. So we're going to multiply top and bottom by a radical 8, radical 8. And when we multiply those across, you can take 3 times 8. That'll give you a radical 24. And on the bottom, you get square root of 8 times square root of 8 is a square root of 64, or just an 8. Now we're going to have to double check to see if we can simplify your radical 24. So if you have radical 24, can you do a factor tree and reduce it? So you have 2 times 12, 2 times 6, 2 times 3. So we do have a pair of 2's here that we can take out. This 2 and this 3 are going to stay underneath, so we're going to have your radical 24 really turns into being a 2 radical 6 all over 8. And once again, we can simplify any fractions that are on the outside. So we can make this a radical 6, a 1 out front, because that becomes a 1, this becomes a 4. Or we can just write it as a radical 6 over 4. So 15 is done the same way. I'm not going to do that one. You can try it on your own if you want. 16 is done the same way. 17 is a little different just because you have a variables, but that's okay. We can still do that. So we're going to multiply top and bottom by a square root of 12 x squared y to the 6th. And you could actually simplify this before and make your life a little easier. Or we can go ahead and multiply across. So when we multiply these across, 9 times 12 is going to give you a 108. Now your x's, you add those. So 5 and 2 is a 7. 1 and 6 is a 7. So since we have odd exponents, we're going to have a remainder. On bottom, we just end up with a 12 x squared y to the 6th. So we need to simplify this fraction up here. So we're going to take our 108, we're going to do a factor tree. So you have 2 and 54, 2 and 27, 3 and 9, and 3 and 3. So pairs, we have a pair of 2s, we have a pair of 3s, and you have a 3 all by its lonesome. So this ends up being a 2 times 3 on the outside, which is a 6. And then you're going to have a radical 3. Now if we want to simplify your exponents, we're going to take your 7, and you're going to divide that by 2. 7 divided by 2 is, well, 2 goes in there 3 times. So you get a 6 with a remainder of 1. So that means we're going to have an x to the third with a remainder of 1, which means we're going to have x to the first underneath. And you do the same thing with your y to the 7th. So that's going to be y to the third with the remainder of y to the first underneath. And all this is still divided by 12x squared y to the 6. So we can simplify, finally, this will be our last step, your 6 and your 12. Well, that becomes a 1, this becomes a 2. You have 2 x's on bottom, you have 3 on top, so that becomes an x. You have 6 y's on bottom and 3 on top, so you have y cubed on the bottom. Remember, anything that's underneath the radical cannot be simplified, so you leave it like that. So all we have on the outside is an x, and then you have a radical 3xy all over 2y cubed. So that would be the most difficult problem I believe that you would have. And that is how you can simplify by division.